we often encounter 5 nanometers and 7 nanometers chips. It's easy to get a logistics illusion. Do you know the size of 1 nanometer? Just take a small knife. Compared to bacteria visible only under a microscope, these bacteria have diameters from 500 to 5,000 nanometers. Of course, here refers to nanometers, referring to the distance between the 3 poles on the chip. If we liken the chip to the brain of a phone, when the brain is in operation, the electric current needs to flow from the transistor source to the drain. The intermediate gate is essentially a mountain with 3 levels. So, is a 5 nanometers chip really better than a 7 nanometers chip? The answer is yes, because there is loss. When the electric current passes through 3 levels, it's like you, with full health, traveling from city A to city B. But there is a thorny path on the way. The more thorns, the more health you lose. But if the thorny path becomes shorter, will you have more remaining health? On this chip, the size of a fingernail, there are roughly tens of billions of transistors. If the ridges of each transistor are reduced from 7 nanometers to 5 nanometers, the chip of the same size can accommodate more transistors. For example, a 5 nanometers chip can accommodate 170 million transistors per square millimeter, an 80% increase compared to 7 nanometers. A 5 nanometers chip can accommodate 170 million transistors per square millimeter, an 80% increase compared to 7 nanometers. It can accommodate 170 million transistors per square millimeter, while significantly improving chip performance. Power consumption is also reduced, but making 5 nanometers chips is not easy. Currently, there are only about 10 companies worldwide that can produce 28 nanometers chips. Do you know why?